And yeah, thank you for coming. A little bit about myself. I'm currently working in Skymind AI Berhad as a deep learning engineer. And my current focus is to train, to deploy models on the cloud and also the mobile devices. And my personal interest is creating AI applications, open source projects, and also personally I like to join hackathons. And my past work experience is I have worked in Intel Penang, a little bit involved in validating and benchmarking of computer vision and deep learning algorithms in OpenVINO toolkit. Have you guys heard of it? Right. And I've also has experience in integrating these AI applications in different OSs and different hardware. Okay, so before I continue, may I have a show of hands, like how many people here are coders or any person involved in software? Can I get a raise of hands? And coders, like you do actual programming, any kind of programming. Yeah. How many hands? Everyone? Okay, welcome. Okay, besides coders, can I get how many hands who do deep learning, AI, machine learning kind of code? How many? Even if you test it or you even develop your own one, can I get a raise of hands? Many hands around. Okay. I thought you mentioned you self-taught, right? Self-taught is also actually a kind of learning, right? Okay. So welcome. And how many again from this pool of people use Python to do deep learning AI, right? Python can be C, C++, right? Maybe they are kind of stuff. All right. Without further ado, let me share with you what is the outline for today's talk. So before going into deep, I will share an overview of what is deep learning. After that, I will explain more about open source deep learning framework, which is Deep Learning 4J. In short, it's Deep Learning for Java, and what are the essentials component of the framework. Aside from that, today the main goal idea is to show how do you run deep learning functionality on mobile devices, which is on Android for today. I'm going to show you the essentials of how to create your very own first Android application, a very basic one. Yeah, but the basic I will have deep learning function in it. Okay, after covering all the essentials, I'm going to walk you through when you're deploying deep learning in production, what are those scenarios that you're going to face, right? What are the challenges? Besides all the explanation, I will going to show you a few demos here. I have prepared 2 demo apps for today's session. The first one is called a emptiness classifier, which the app actually trains a deep learning model on the phone itself, and it also does prediction, handwritten digit classification prediction. The next one, the second one, is a tiny YOLO real-time object detection app, where you can point your camera or you can capture an image and you do object detection. All right. If those who are new don't know what is object detection, I'm going to show you what are the examples of it. And enough of the demo. We will end this session with a question and answer session, Q&A session, where I'll try my best to answer what questions that you guys have in mind. Again, ask questions. Just ask any questions, even if you're shy or whatever. Yeah. So, without wasting more time, let's just go in and see what is deep learning. So, let me start off with a few real-world use cases. The first one is object detection, where you have a camera frame or an image. You can see that there are bounding boxes showing an object is within the frame. For example, you see that, let's say that section is a car, and you label it as a car, and in result-wise, you actually know where the object is in the frame. That is object detection. And another cool way of using deep learning is image segmentation. You can use it in the medical field. For example, let's say you have X-ray scan of a brain, and you can perform image segmentation to show which part of the brain has the tumor or any affected parts. Right. Then, more popular examples is image classification, where you give the app to know, you show it an image and it will classify the image as a kind of you classify the image as what is the image, right? Let's say for this one on the left, I feed in a picture of an orangutan. It has a prediction that it is orangutan that have 96% confidence. Here, you know that what the picture is, but you do not know. Let's say you say that it's an orangutan, but you don't know where is the orangutan inside the picture, right? You don't have localization. Okay, a more easier to understand example here. You guys know this face app, which is quite famous recently, where you can generate your face. How does it look like in a certain age, and also you can, even if you don't have glasses on, you will generate glasses on your face, and even if you're not smiling, you have a generated smile here. This is face app. You guys have used it before. I put this example because it can relate to the apps that you see in your life. Yeah. So this kind of deep learning applications is you can call it a generative networks, where you generate stuff instead of a discriminative network. Okay, so you have seen the common examples nowadays. That four is not the only application. You can have many other more applications out there in the industry, or for fun's sake, right? You can have all tons of applications. So when you start learning deep learning, right, you might find it hard to differentiate what is AI, what is machine learning, what is deep learning. So to put it in simple words, AI is the broadest field. It covers everything. And a subset of AI is machine learning. And then another subset of machine learning is deep learning. All right. So what is AI? It started in 1950s to 1980s, where you can consider any technique that enable computers to mimic human behavior. That is AI. It's like very general, right? And then in machine learning, in 1980s to 2010, it is a subset of AI techniques which use statistical methods, right, to enable machine to learn and improve through the experience. Hence the machine learning, right? And then you have the recently famous, not recently, it's quite long for some time already, deep learning in 2010 until the present day, which you use multi-layer neural networks to do your computation. And in today's application, you can feel that it is more feasible. So deep learning, machine learning, AI. So in the earlier days, learning AI or learning machine learning can be a challenge. And why? Because in the olden days or the earlier days, we have limitations in our computer, right? We have limited CPU, GPU power. I mean, to do a machine learning project, you might need to invest in very expensive CPU or very expensive GPUs. But as the time passed, because of Moore's law, in CPU wise, the computation gets better and better, right? So you can get a more powerful device at a cheaper price nowadays. So expensive computation is a barrier to learning machine learning or deep learning in the earlier days. And besides that, something that hinders people from learning AI is that people do lack mathematical understanding of how does the algorithm works. Because of that, because it is so not common, people find it hard to find information online, right? If you want to do self-taught, last time I don't think that if someone will write a blog about this machine learning algorithm. Last time, in comparison, when you want to learn stuff is harder. And now you can find blogs, guides, or official documentation everywhere. And any framework that you want, right? That is the challenges in the earlier days. So in now, there's no excuses, right? So why do we want to learn deep learning why do we want to learn deep learning now? Again, big data is a buzzword where the growth of internet has actually generated massive amounts of data out there. Data is everywhere, all sorts of data. Like you have people spying data or right, all sorts of data everywhere. So you can get data unethically, and you also a lot of organizations actually open up their data for users to use them to create meaningful applications, right? More organizations are more open to share data sets out there that you can use them to create a specific deep learning app. Okay? And again, CPU, GPU are cheaper now compared to last time. You have better CPU, GPU, and even now you have, when you're doing inferencing, many people have launched out like TPUs, like ASIC, which is application specific IC, integrated chip, which you can do the inferencing faster, means the prediction you can run faster, right? Hardware nowadays is more accessible, right? And even if you don't have the physical hardware, you can actually rent or you can actually use cloud computers. Some like Google Colab, which they give you for free, you can let it use for free, and some you can rent it without buying actually the whole device, right? And another reason why you should learn deep learning now is that in the industry is now there are so many opportunities in the industry, right? There are so many use cases not yet implemented in the industry. Yeah, why? I believe it's because that there's not much exposure to them. They lack of the exposure. So with the correct people and the correct business, you can come up with something new or innovative. And again, not an excuse. The source of information is easier to get now, right? You have research paper. Let's say you have a newest state-of-the-art algorithm. You can simply just go online and just read the paper. They'll just let you read the paper. You have research papers. You have blogs, like people use TensorFlow, and they write up a blog. You can just go and read about it. Yeah, and a certain framework has a blog, and you can read and learn how to use it without actually paying to learn something. Right? You can do it self-taught and also open source projects. Let's say, GitHub nowadays, people just do something and post all their codes on GitHub, and you can just go in, clone their project, and just use their pre-trained weights and run. You can directly run the application. Okay, so when do actually deep learning become really, really famous? In the year 2015, we saw that the AI algorithm actually surpassed a human's ability to recognize an image. That's when it actually became famous, like during the AlexNet, right? The starting point, right? So what is ImageNet challenge? Usually all these algorithms, how do you evaluate that how good your algorithm does is actually they go into a challenge to see that who has the greatest accuracy. Yeah, those challenges. One of it, the very famous one, is called ImageNet challenge. It is there since 2010. The challenge is actually trying to evaluate how good is the algorithm in doing object detection and image recognition. Okay, deep learning is very broad, right? It is not only a few. There's a lot you can see here, from the simplest perceptron to a feed-forward network, and all the way to depend on how creative is the researcher, right? For example, you have a few like famous ones like convolution neural networks. You have LSTM, long short-term memory, and you have generative adversarial networks, and many more. It depends on the researcher. Maybe they have an idea how to improve the accuracy, then they have a new architecture for you to follow, or for you to tweak and have a better result. So why use deep learning and in comparison to machine learning? For example, machine learning have a few algorithms that are famous, like logistic regression. decision trees, and support vector machines, and many more. So why do we want to specifically use deep learning, all these neural networks? Again, it is proven that deep learning works better with when you give it more data, you feed in more data for it to train. It is proven to work better in compared to machine learning. And one of the key factors of deep learning is that deep learning does automatic feature extraction. So this feature extraction can be done on images, which is raw image pixels. It can be done on text. It can be done on soundtracks, the signal waveform, and much more, any data that you can think of, right? Yeah. Deep learning neural networks can improve your performance in terms of accuracy when you compare to machine learning. Most of the cases, right? Again, when trained on more data, and automatic feature extraction, you can done on images. So let's say an image of a cat. In the machine learning way, you actually set what is the filter that you might use to get a better extraction of like edges and stuff. So for deep learning, it can automatically extract the features of like colors, the edges, the texture, and also the outline of the object. And for text data, it might be extracting features of keywords, the numbers, and the length of the text. And for speech, it can be extracting features like the pitch of the sound wave, the pauses, and the use of words. So if you don't know what is features, I will show you in the slide later on. Right. So deep learning, automatic feature extraction. Why deep learning again? Again, in real world and our smart brain, we actually understand complex relationships between things and around us. So for computers, for neural networks, it has the ability to learn the non-linear and complex relationships between features. Okay, it might sound a bit confusing, but you can see later on. Again, a little bit of maths. Linear is like you have a linear relationship, which is a straight line, and non-linear relationship is something like non-straight, like curve around here. Okay, so I actually straight away start with what is deep learning, and I didn't properly introduce where do I come from. Again, a little bit about the company that I work in, which is Skymind. So what do Skymind do here and in the US? Skymind actually builds the AI infrastructure to operate models in production. So production means in production, we have a lot of apps that is running on Java virtual machine, right? So that's where the production means here. And the infrastructure actually allows the model to be accessed from the cloud, any server, a desktop, or also the mobile. Skymind also provide tools to keep track of the revision of the trained model, right? If you train model, you need to keep track of it, and also you can monitor the accuracy over the time. And besides the AI infrastructure, Skymind actually have a very significant product. Here is an open source AI deep learning framework, which is deep learning 4J, deep learning for Java. Okay, the open source project is enabling people and developers to do deep learning in the Java programming language. And again, because of this open source project and also the past experiences, we serve large enterprise globally, from the range of banking all the way to e-commerce. 2 projects here. The first one is the model server, which is closed source, meaning it's not free. We have model server here where a little bit of stats here is that we have more than 1 million Docker pulls since 2017, and also deep learning 4J, which is the open source deep learning framework. And you might notice that there's a word here in front, which is Eclipse. anyone heard of Eclipse before? It's for in Java, right? Eclipse is the foundation where you accept in Java projects which is stable and good for use to the community, right? And our open source project have a lot of activity within it. You have multiple forks, stars, and downloads, and also we have many contributors. And yeah, we also have an active chat on GitHub where you can ask questions and they will help you to solve your may it be small or big issue, right? So Skymind in Asia or Southeast Asia, we provide AI infrastructure to operate models in production. In technology-wise, we provide deep learning 4J, which is we provide some support for the open source project, and also we have the model server, which you have the infrastructure to serve your model in production. And besides the technology side of business, our services, some of the services that we provide is we have training where we help people who are new to deep learning get certification and get some training to learn more about deep learning. And also we provide support, right? So what is model server here is that this product enables you to have workspaces where you have like notebooks. You can import notebooks and do experimentation of your model. And then right after you do it, you can go right to deploying it, right? For more information, you can contact us later. Yeah, this is the rough idea. And the whole skill platform can be run on, depending on what hardware that you're running it on, right? It can be Intel CPU, NVIDIA GPU, or some rare cases, some ARM kind of hardware. So there are two co-founders that founded up this company. First of all is Adam Gibson, which is our chief scientist. He also wrote a book about deep learning, and we also have our CEO, Chris Nicholson, which built our team here. I mean, the US up until here. So a little bit of publicity. Adam Gibson wrote a book called Deep Learning, a Practitioner's Approach. So they have this book, and yeah, you can, if you are interested, you can purchase it on Amazon or something to read about it. Yeah, the book will show you some fundamentals of deep learning and also examples to use DR4J. And also we have another employee that wrote a book. It's about deep learning and the game of Go. You guys know Go in deep learning or AI? Some people, they have like videos of human versus computer in the game of playing the Go. Yeah, you guys can Google it up to see what is it. Okay, a few of our members are actually top contributors of Keras. Yeah, they are in the team. Okay, so why is model server important here? It's correct that you can train your model using data sets, right? And you get a proof of concept, and it's done. But in production or in the industrial level, you need to build multiple models. It's not only one model, right? Let's say the model A have this certain accuracy, and your second model B is having another accuracy. So you need to actually keep track of the revision and the history, right? So that is the importance of model versioning, because you can train your model based on different data sets, right? There are so many data sets out there, and you can train your model depending on different hyperparameters. So what are hyperparameters? It is something that you tweak a bit and you can have a different accuracy value. Yeah, this is the reason to have model revision tracking. And again, a model server will help you deploy your model either through REST API or maybe through real-time. Yeah, it depends. And again, if you wish to know more, you can contact us through email. Yeah. Okay. Okay, before this, so that side, you know about the company and you know about roughly a bit of idea on what is deep learning, AI, machine learning. So now I'm going to share about the deep learning framework, DR4J here. Again, Eclipse DR4J. For definition, DR4J is an open source deep learning library or framework that enables programmers to design and train their neural network using their native language, which is Java or Scala, right? So usually, I believe most of the deep learning framework out there are using Python. So with the Eclipse DR4J, you can actually do deep learning. You can build your model, deploy a model in your favorite native language, Java. So you might ask, why do I want to use deep learning 4J? Again, if you don't know Python or you don't know C or something, you are a pure Java programmer guy, you can just get started on deep learning using this language, using this deep learning framework. You can comfortably design your neural network in this language. Again, besides have the privilege to design in your own language, the deep learning 4J actually use a library called ND4J, N-dimensional array for Java, which is a scientific computing library for matrix computation, and it is considered fast. So in other words, in more familiar words, you can say this is something like NumPy in Python. Okay, and again, deep learning 4J does not only cover make you run on CPU. It is also available in NVIDIA GPUs. So when you train your network with a certain correct configuration, you can train your model and deploy your model using the NVIDIA GPU, right? And again, deep learning 4J is meant for production applications, which is like big data or systems that have multiple incoming streams of data. And you can do something called distributed deep learning, where you can train a model on different servers, and you have distributed training. And you can read more about it on this link. That you can click on it. Yeah, there's a library that you can use called Spark. So it's meant for that you can do distributed deep learning using DR4J. Again, why do you need to use deep learning 4J is that it supports multiple programming languages. It supports, for big data field, it supports Scala and Spark. And for today's session, it also, DR4J actually covers using Java and Kotlin for mobile device type of programming development. So today I'm going to use Java on Android, and Kotlin is kind of new, so I'm not touching on that. Yeah. Some core components of Eclipse Deep Learning 4J is that you have the core component here, Deep Learning 4J, where you use it to build and train neural networks in JVM, Java Virtual Machine, and also Spark. Besides that, again, you have ND4J, or the library libND4J, which is a high-performance linear algebra library, which we use it for computation of matrices in GPU or CPU. Again, it's more something like NumPy for JVM. And you have something called DataVec, where you use it to bring in your data, you pre-process or transform your data, and later you pass it to the section where you actually train the model, right? DataVec is where you use it for extract, transform, and load. And then we have something called model import, where you can actually import models trained using Keras, TensorFlow, and also some neural network that is converted through the framework called Onyx, Open Neural Network Exchange. Yeah, you can import the model in and see how we're gonna use it. And also we have something called Arbiter, which we use it for fine tuning. Something like you do a search for the best hyperparameters. Yeah, is used for fine tuning. And we have a few more subcomponents like RL4J reinforcement learning on Java. Yeah. Okay, so up until now, I have covered all the deep learning side of the presentation today. And before moving on, I will show you the basic that you need to know to create your first Android app. Because today's agenda is to actually run an Android app with deep learning capability. So we need to learn section and pieces by pieces. Okay. So just now side is all the deep learning knowledge that you need to know, the basic one. And now we're gonna go into Android app development. So anyone create their own apps before? Any apps? Like, yeah, all sort of apps. Because apps nowadays, so everything must have an app nowadays, yeah. Okay, so at least maybe you can create an app after today, yeah. We'll see. So let's say you are beginning on creating your first ever app in Android. Again, apps you have two kinds, right? You have Android apps, you have iOS apps. So today I'm going to cover the Android side of it. Let's say you are new, you're a beginner. You'll probably use this tool called Android Studio, which is created by Google and JetBrains. And if you're going to code in Java or the newer fancy language Kotlin. It depends on you, right? So for me, I'm going to use Java today. And this whole Android Studio, how it works is it will use a tool called Gradle. It's a very important tool because it uses it to build your code to the actual application. So you gotta know how to set your Gradle, okay? And again, Android Studio, you have the ability to actually import different modules from the Maven repository. If you're doing Java, I believe you will use Maven modules from Maven, right? Yeah, for Android Studio, it's the same. You can import different modules into your code. So for here, if you're creating a normal app, maybe you will not import any modules. So if you're going to do a deep learning app, easiest to reach is Deep Learning 4J. You will just import, then you can get the API. You can start coding in. Yeah. Again, a lot of things you need to take care of when creating your first ever app. A beginner is quite confusing. First of all, your Android OS. How many people here is using Android? Raise your hands. And the rest is iOS, right? Okay, never mind. So Android OS, you have so many versions all the way from Marshmallow until now is Pi or Oreo, right? So when you're developing your app, you need to know that what's your target device. The best case is that you cover all devices, but if you do that, maybe your station will have a lot of extra SDKs, right? The best is that you need to know that what is the target OS level that you're trying to deploy. So yeah, things will be much more cleaner like that. So you can set like minimum or target API level. So for example, here, you look in this table, you can see that this is the name. Yeah, when you do to be fancy, you actually call this Android Marshmallow, but in reality, it's actually just Android version 6. Okay, so the latest one, if I'm not wrong, is Q, where they don't call it Q something or dessert, they call it Android 10. Sorry, Android 10. Yeah. So after you know that what version or API level that you're gonna use, you need to set it in your code. So there are a lot of codes here, not only one code, like many settings or configuration file that you need to set. First of all, the first thing you need to do is you go to this path. Again, it depends on your project, your Android project, and you go to the app folder and this file, build Gradle. As you can see here, you can set like the minimum SDK version and also your target SDK version. Okay. Again, an Android app is not only all coding. You need to take care of the aesthetic part of it, which is the UI or the front end. It's more like a website, right? Where you have the underlying backend logic code, and also you have the fancy interface where yeah. Same for app, just like websites, you need to design your front end code, which is the UI. As you can see here, all these it looks like one picture, but actually it's a lot of components here. This is an image, this is a text, another image, this is a button, this is an image also, a text, but it can be coming from a certain variable. This is the aesthetic part, the UI part. And on the back end, which put the logic into your code, is all this Java code, right? For this is a code to how to build a network. Okay. Not only this, it's actually a lot of code where you actually say something like, if you click this button, you go to this activity and something like that. You need to correctly create all this logic behind it to make your app work. If not, something error, then it'll crash. So be careful. Okay, so in a normal programming way of style of doing things is that you have a main code, maybe main.cpp or Python with a main function, right? So in Java, or for Android way of doing it, you must have at least one activity for a usual common app. You can debate that you can create like headless activities or headless services. That is another thing. So for today, I'm going to show you how to create an app which has a UI in it. So again, we'll start off with backend code. You'll have something like main activity.java. It not necessarily that you need to name it this, but I put it here because most of the people use this name. So this is the main activity, and most of your codes will start off from this code. Okay, that's why it's called the main. So going to the front end side of the work, you have again activity underscore main.xml. This is the place where you design your UI. It's not entirely using text. You can actually use drag drop. It's very fun. And again, you can create multiple pages of UI and multiple activities, but you need to prepare them correctly, right? And this UI is actually expressed in layouts. And layout is like how the structure of your things, how you're going to structure it. You have a few versions of layouts. You start off from the most simplest one is linear layouts, relative layouts, which is more complex one, and a newer version called constraint layouts. Yeah, you guys can Google and see what's the difference between them. Again, you can use, when designing the UI, you can use drag drop, which is awesome. And what are the components that you can use? Some examples are, again, text view, where you can show text. It can be those widgets where you can type in words. Those are sub-components of it. And you can also have image view, where you display images, and also buttons. Important, right? Buttons. Tap it. Okay. So you have something like this, where you have text view, button, blah, blah, blah. You can just click it and drag and drop. You will see it later when I open up the IDE. Enough of the code. Next is to make sure that your app actually compiles successfully and is able to run. That is key point, right? It doesn't matter when you can code all sorts of stuff. Yeah, you need to make sure that it can be built and it can be run on some devices. So again, grader is very important. Make sure you set the correct version of your grader and also the plugin for Android. So you have two here. You have Android grader plugin version and also grader version. If you ask me, what's the best version that I should always use? It really needs to depend, right? Again, versioning, it depends. Or in terms of software, let's say this release might work on this version of stuff. Yeah, it needs to depend on you, right? So the best is to test it out yourself. Again, you're going to set the correct version. If it don't work, yeah, just change to another version and try to see whether it works or not. Okay, Gradle is where you also import your modules, your dependencies. Again, I give you the path to it so it won't be so clumsy. Again, when you're trying to develop an app, it doesn't make sense when you use Vim command line to do this kind of programming. You torture yourself, right? Don't do that. Please don't do that. Use an IDE because you need to see where your code run here and run there. Again, Java is an object-oriented programming and you have multiple codes. It's not only one code or a script. You need to jump here, jump there, right? You have import classes, import some methods or functions, right? Yeah. Again, this is where you find your Gradle file, and this is the place where you import the modules. For example, import Deep Learning 4J module. Okay. Besides Gradle, there's one more file called Android Manifest. To be precise, is this part, Android Manifest.xml. I'll show you nicely here. You can know where to find it. Here is the place where you define which activity is your default activity. Meaning when you start an app, which is the activity that you launch first. Let's say you have 10 activities. If you don't set the default one, how do you know which one to start? Right? You need to set your default activity here. And also, when you create more than one new activity, you also need to include this in your manifest. Also, the manifest is also the place where you set your permissions, like permission to open your camera, permissions to access your internet, permissions to save file to your external storage. Again, privacy is a big issue, raise a big alarm, right? You need to set permissions to make sure your app doesn't spy on you, use your camera for some bad reasons, right? Yeah, here is the place where you set it. To sum it all up, for a typical working application with UI, you will have components with correct configurations as below. Make sure your Gradle is set correctly. Make sure you have at least one activity, one UI. Again, pair them correctly, and have a manifest file. With all these 4 files at least correctly done, you can have a basic app. Maybe you click the button and you say hello, something like that, right? Yeah. Okay. Coding essentials you already know. So what happens when you actually click the run button? What does it do? So again, application for Android. Usually, how do you download apps? You go to the Play Store, click download, and the thing will just come in there. It just works, right? So, if you're trying to do yourself, you'll probably generate an APK file. I'm not sure anyone play with their phone. They install some weird apps. It is on .apk, and maybe it's not signed. Signed means signed for security. You pass some Google Play Store security license. Yeah, all these unknown or unsigned application usually comes in .apk. So when you do your app, same. Maybe it's not signed by Google Play Store yet. So it is a .apk file. So when you click the run, when you compile your source code to a runnable file, what does it actually do in the background? The app, the source code is compiled, it is zipped, it is converted, and all the Java code, all your resources like images and stuff, all compiled and zipped to a single APK file. Okay? And this APK file or this app will be running on a virtual machine in your phone. And the virtual machine is called Dalvik Virtual Machine. This is for Android. And again, when you build your app, maybe you want to share with a friend, you will actually be saved in this path, like builds output APK debug, this name. Maybe you can rename it, share around with your friends, or prototypes, right? So if you know that when I do Android applications, you code in Java, right? Java code, how it works is, when you do compilation, it will compile to a jar file, which is Java bytecode. And then it will then also be converted to, from jar, it will convert to DEX file, which is a Dalvik executable. Hence, you can run this on a Dalvik virtual machine. Alright? Okay. We code our app, how we're going to do, what function it will provide. We build it for some time. And then we need to run it to see whether it works or not, right? So how do you run an app on a computer? How do you do it? So luckily, we have something called Android Virtual Device, which is AVD in short. You can run your app, your prototype app on a virtual device hosted on your main computer, which is very heavy. And then you can do that, or you can actually, if you have Android phone, right? Android phone, you can run it on your Android phone. Even if you can take the risk, depend on you. Yeah, you can deploy on the virtual device or run on your actual mobile device. But if you want to run on your mobile device, you need to set developer options and enable USB debugging. Yeah. Before we take a break for 5-minute break, we're gonna see one last component which you need to know is, let's say your app is running, so if everything seems fine, but you need to check what all the services, all the codes are actually doing in the background. So you need to check out the logs. So where you're gonna see it is at the logcat. Something called logcat, something like here. You choose your device, you choose the activity, and you can filter. You can filter your logs depending on the level of your log. Let's say a debug log, info log, warnings, errors. You can filter by that. And also you can filter depending on the tag, a certain filter that you set. Right? Maybe you put haha, then you can filter using haha, right? Then you can see the certain logs that you want to see.